All right, so here's another example where we are going to subtract rational numbers. This time we have fractions, and so we're going to figure out what we need to do. I also noticed that we have a double sign. So remember, we talked about that as well. So we'll figure out how to find the correct answer on that. So if we go into, let's see what we're going to do first. First, let's write down our information. So we're going to write down 5 and 1/3 and subtract -4 and 5/9. Okay, first things first, um, we want to get rid of those double signs, right? So remember, we're going to look at it as if, and when I say get rid of those double signs, let me explain how I look at it. I look at it as if I am saying, because the double signs apply to multiplication and division. And so under multiplication and division, we know that if we have two of a kind, it becomes a positive. That could be the same for two negatives, that's still a positive. And if it's one of a kind, or positive times a negative, then it is going to be a negative. Okay. So, not under addition and subtraction, that doesn't apply. But every time that I look at something like this, I look at it as if there is an imaginary one sitting here. Okay. And so what I'm saying is I am multiplying -1 times one set of -4 and 5/9. So I'm looking at it as a multiplication problem to help me get rid of those double signs. And so when we look at those double signs, let's see what happens. Two negatives become a positive, right? So that's going to become a positive. So I'm going to rewrite it. So now we have 5 and 1/3 plus 4 and 5/9. Now, the next thing that we need to look at is our fractions. Do we have terminating fraction decimals? Do we have repeating decimals? So I know my thirds, and I know that thirds are considered to be repeating, right? So we definitely need to convert this into fraction form if we want the most accurate answer. 5/9 I think is also repeating decimal as well, but let's see. So 5 ABC 9 second backspace, and no, that's actually a repeating decimal as well. Another way, remember, that you can do it is if you're looking at the fractional amount only, so the 5/9, you can also use division, right? 5 divided by 9, and we get the same thing. So both of those are repeating decimals. So we need to go on and convert, keep everything as a decimal. We have right now a mixed number. A mixed number means you have at least one whole and you have a partial number. So that's a mixed number. So what we're going to do is we're going to convert it into an improper fraction. In order for us to do that, I want you to go back to remembering about Texas. And we're going to use this throughout our examples. So we're talking about Texas on both of these. We're going to start from the bottom, work our way to the top on converting these into improper fractions. So what we have here is 3 times 5. That gives me 15, and 15 plus one more gives me 16. Remember, your denominator will stay the same, right? So that's going to stay at 3. Plus 4 times 9, or 9 times 4, that's 36. 36 plus 5, that's 41. So we have 41 ninths, okay? Now what we need is an LCD. That's a lowest common denominator. Right now, because we have a 3 and we have a 9. So what do we need for us to figure that out? So when you're looking for the LCD, what you're doing is going to look up, first find your LCM. That's your lowest common multiple. So we have 3 and 9, and we're trying to find out where do we have something in common. Okay, so we're counting by 3. So this is 3, 6, 9. And this one will be 9, and there's our commonality. We both have a 9. That's the smallest number that we have in common between the two of them. So that is going to be our LCD. Our LCD is going to become 9. So LCD is 9. All right, so let's rewrite our problem with our LCD now. So we have, I'm going to slide this up just a little bit. All right, so now we have 16/3, and before I get started, let's try to figure out how do we get the denominator to become a 9. So let's look back up here. What would I have to multiply 3 by to get 9? Well, it would be 3, right? And then what do I multiply 9 by to get 9? Well, that would be 1. So that's what we're going to use when we rewrite our fractions down here. So 3 times 16 gives me, what is that? 48. 3 times 16 gives me 48. And then we have 3 times 3, that gives me 9. Plus 1 times 41, that gives me 41. 1 times 9 gives me 9. And so now what we're going to do is add those together. So we're going to put 48 plus 41, and we're talking about over 9. Remember, when you are adding and subtracting fractions, your denominator has to stay the same. That never changes. All the way across, it should be the same. So 41 plus 48, if you plug that into your calculator, you'll come out with 89 ninths. Okay. Now notice that our numerator is greater than our denominator. What that tells me is there's a whole number inside of there because the fraction is meant to break one whole into smaller pieces. So your numerator should ideally be smaller than your denominator. If it's not, then that tells you, hey, you've got some whole numbers in there. And so we need to take those out. So what we're saying is, let's say that I have 89 of something. I have 89 of something, and I am going to take them out in groups of 9. Well, how many groups of 9 would I have? Well, if we count by nines, 9 times 9 would give me 81. And remember Texas. So we're going to remember Texas as we work through this problem here. So we're going to remember that. All right. So 9 times what to give me as close as I can. 9. Well, we had 9. 9 times 9 gives me 81. And how many more do I need to add in to get back to 89? Well, you just add back in 8. So your answer is going to be 9 and 8 ninths. That's in its simplest form. You cannot reduce it anymore. Now let me show you how you would type that into your calculator. So you could plug in, remember your ABC keys. I'm going to slide this over just a little bit. All right, so you can plug in 5, ABC 1, ABC 3. So we have 5 and 1/3. Then we're going to subtract out. I see a negative, but remember, in order for you to convert to a negative, you first got to put a number in. So let's put our next number in. So we're subtracting 4, ABC 5, ABC 9, and then convert that into a negative, right? And then let's see what our answer is. So we get 9 and 8 ninths. So that's the same thing. Remember, because it was a repeating decimal, we could not convert it into a decimal form. Well, you could, but it would just be an estimate. It wouldn't be exact. So we're going to leave it as a fraction form. But if you turned it into a decimal, let's see what would happen. See, you see it's a repeating decimal, right? And the only reason we see that 9 at the end is because we didn't have enough spaces for us to continue with the 8s. So I'm going to turn it back into a fraction. So I'm going to hit that second button and the backspace, and now we're back into our fraction. So our answer is going to be 9 and 8 ninths.